Oh, thank you.
Okay, I quickly check to see the time. See any problem with the time here?
So what are we doing right now? Just waiting?
Oh, you take the quiz. For now, you just write out the paper. Number one, you select A or B or C or D. Okay? I think you need to download this quiz from Handout.
Got it. Well, I have another question. Is this part of what we studied last week? Because I don't remember studying with two different grounds.
That's the last week.
And we studied the connections with two different grounds?
What do you mean different ground? That's only one. Ground will be the same.
Okay, what does the VO means?
VO.
Yeah, I don't remember going over something like this.
Okay, you guys ready for this slide? If okay, then I can move to the next one. I still get problem with the timer, but that's okay.
Let's move to you.
Okay, we'll move.
So this quiz correspond to the handout number 2.
Get the from the first handout for the DC. I think handout for number 2, we're talking about something else. No matter what, you see you can do it or not. So that's why we look it back in order to help you guys.
Well, I reviewed the whole handout and I did the other quizzes and they were based on the first handout. But this image or circuit is not present in the first handout.
That is not exactly the same, but regarding they will be including in the first handout or this for the DC. If you understand the handout for the first one on the DC, then you're supposed able to get through this thing. Make sure you must read the handout too many times.
Okay, I'll do that. Thank you.
Yeah, no problem. Keep reading. Anything not quite understand, then you can ask, okay? We help you out. And make sure whoever wants to meet with me in the Zoom at a different time, just text to me. And also, we let you guys know, my email is changing from Yahoo to the Gmail. Yahoo is too slow.
But the same user ID, only change for Gmail.
Yeah, just change from Yahoo to Gmail. Name still the same thing. And the text you, you're supposed to get it done quickly and get it the right one.
Okay, like Mr. Pham said, this is just a quiz, so make sure you take it. He will go over this quiz later on, so he will show you how to work those problems.
Yeah,
But right now,
this
he just wants to see if you can do it from what he covered last week, okay?
after this one, I will be go over right away for the right answer. And any question? So you done on number 2, slide number 2. I don't know why hammers go up.
Time to learn more.
Yeah, I fighting with that. Take a lot of time.
Yes.
Okay, we go tonight.
It looks as if there are duplicate slides in the quiz. I think 4 and 5 are the same slide.
You mean number 4 and 5?
I think so. Hang on.
Different.
No, I'm pretty sure that slides 4 and 5 are the same slide.
So it look like this question number 5 and 6. This is the series circuit. Yeah, he did cover the series circuit last week.
Slides 4 and 5 are the same slide.
Okay, we will get later. Okay. We try to get to that thing. Make sure, on the other one, we don't have a R3, I believe so. Who get the answer for number 5?
I think it's D, Mr. Fan.
A, B, C, D. Which one?
The simulation says D is none of the above because VB grounds out.
No, I think it's C. 50 volts applied to 50 ohms is 1 amp because the output of R1 is shorted to ground.
Yeah, you're a good technician. That's what I said. You are tech Joe, then you can get it answer right away. And how about number 6?
I think B.
A, B, C, D. Which one?
B maybe.
5 is D.
I can tell you 5 will be C.
And
number 6?
Yeah,
6
5 is
is
C.
6 is A.
Right.
6 is A, correct.
It will be A. I will explain to you. We can get about 3 more questions.
Okay. Yes.
6
yes.
is egg, it gets shunted to the ground.
Oh, okay. Yeah.
This is a question for engineering. Tricky.
C. Okay.
Okay, we now go next. It's not calculation, just multiple choice. See which one is correct.
Mm. B. C.
Yep, it's B. If the voltage is constant and the resistance goes
Depending.
up, then the current goes up.
Okay, we'll go to the next one. This one we already done. How come something screw up?
You have two of them.
Yeah, that's the last one.
Thank you.
B. 9B.
Yeah, B is right. Period is the reciprocal of frequency. So you just take 1/2 megahertz.
10 is B.
The last one, they run okay with the timer. Man, need to change to my iPad so I can go through that with you. Need to stop share that one here. Let's see. See here. Okay. On that one. Okay, the answer will be B. Now, if you're looking in this circuitry here, so basically the current go to the V out, supposed to be 0 amp, right? Is that right?
Right,
Yeah.
there's no place for the current to go. It's an open circuit.
Right, yeah, right.
Open circuit, current equals 0. Okay? So now you can get only this resistor here and that one. Okay, two ways you can do. You can calculate the current, then multiply by R2, then you get VB. However, I'm using the voltage divider. VB equal 40 times R2 divide R1 plus R2. That's the voltage divider law. If you open your handout number 1 for DC and looking into the voltage divider law, make sure you get any question, anything, bring it up. Okay. Number 2, answer will be A. Now, what they want current through R2. You already get a voltage here. That I said 24 volt. So I R2 equal VB divide R2. So that's why you get A. Okay, make sure you're confusing anything. Then Just bring it up. I can help you out.
So in the voltage divider rule, you didn't add any of the other resistances because they're not. Those are the only two interacting with VB, correct? R1 and R2?
Yeah, the thing is the current will be go this way.
Yes.
So that's why you don't care about R3.
Got it.
Okay. Okay,
Makes
so
sense.
okay, so
So if you want it, you try to ignore whatever here.
okay, that makes more sense. So
No current flowing.
40
So you get only one circuitry with R1 and R2.
divided by
Okay,
120
because the
equals-
reason why I was asking is I used the voltage divider rule, but the last time we used it, it was a circuit that was circular. And since this is not a circular circuit, you do not use the other two. So, okay, that makes, yes, okay.
Okay, we go next.
Yeah, when you're testing at a company, they're gonna put a whole bunch of stuff on there. Sometimes you don't need all that. That's why you have to understand where the current is flowing to determine the calculation.
But normally that for your interview job, they're not given a complex circuitry. Very simple. Just requirement for understanding or not. Basic understanding.
Okay.
Actually, this circuit is circular in a way because the two ground points
No,
are
round
actually.
is one round. Okay. Instead, I draw this way. Okay. But we can put two different round,
40.
but they still round.
Times R2.
Okay, now what they want current through R3. We already telling you. Open circuit. I3 0 amp. So the answer will be B.
So
Okay. And the voltage across R3. VR3 Ohm law. Okay. Will be I times R. However, when you say I, you have to know what I. Which one? I1, I2, I3. So basically, they must be I3 times R3. I3 equals 0. So that's why you get 0 volt.
Answer is A.
So the answer will be A. By the way, I want to ask you, what is the voltage at VO? VO here.
It is the same as VB.
Perfect. You're very good. VO equal VB. The reason is no voltage drop across R3. So whatever VB will be the same with the VO. Okay. Now, number 5, they want the current through R1. They want that current here. You must understand one thing. The current will be trying to go to anywhere less resistance. So you get only one wire here, shorted. Okay, that means no resistance. So the current will be go to the route, go this way.
1 ampere.
They not go here. When they short it, they go to the short. Exactly the same your house. When you get short somewhere, everything will be turned off. The thing is the current goes to the short.
The answer is C.
The answer will be, let's see, you take 50 divide to 50, right? So I will be 50 volt. Divide only R1. Okay, so number C. I said this is a trick question.
Question 6, number A. 0.
No.
Fine, number 6. They want the current through R2. Now you know the 0, right? The thing is current go to the short. So answer will be A. Make sure, if you not understand or confusing anything, bring it up. We just started. This is just a second week. You want to be a technician. That means you have to working by your brain. Okay? The thing is you will be a problem solving. Try to fix, circuitry they not working. So that's why you can get paid more and the job will be more skilled. Okay, go night. Number 7, right? 7. B. Okay, you can see V equal I times R. Okay, I equal V divide R. So if R going up, then I must be going down. Okay? So that's why they say inversely proportional. One go up, the other go down. If R going down, that means you get more current.
Makes sense.
If resistance in a circuit is double and voltage remain the same, you understand that I equal V divide R. Okay? If this go double, okay, then voltage remains same and the current is
Half.
Hello, hello. I'm good, guys. Thank you.
let's say the current is double. That means up double down. This is double up. So the answer will be B.
No, I think it's
No,
C.
the current will go down, which means that will be divided in two. No?
Yes.
I believe the answer will be C, right?
Yes.
Yeah.
The answer is C.
The thing I did coming out from left volt, they get a wrong answer. So correct that. C. Okay. That will 7-8, and that will be 7-8. Okay. So that's the wrong one here. Double. The thing is, at this time, I get too many things to do at the beginning for the program. So that's why I get messing up something. Okay, that number.
So what was number 8?
C.
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 C, C.
C. Okay, 9.
Let's see, what was that? Half, the double, the what?
Half.
Half.
That means one going up and the other one going down a half. So my answer will be B on it,
B, correct.
right?
Yep. Yes.
Okay, good.
Right, so right.
See, I saw someone get in under Samsung 5. I said to guy get into the web using first name, last name. So they know how to record it. Otherwise, we don't know who. Okay, last one. Answer will be A.
A,
Okay, you understand the V M at equal, okay, 0.707 times, right? We pick, and they get pick to pick. 20 volt. So we pick a half. Pick to pick, divide by 2. You get 10. That's why you get 0.707.
Yep, that's correct.
If you get correct for 7/10, you're okay. But the perfect, I want it 10/10. Okay, any more questions on this quiz? Okay.
Could you please go over 10 one more time?
10.
Yeah, one more time.
Okay, you know, we pick to pick, they given you 20 volts. Right?
Yeah.
Okay, so we pick a half. We pick to pick will be 10 volt. Right?
Okay.
And the formula to calculate the VIMF, this is the formula. 0.707 times V peak. So they will be 0.707 times 10.
Oh, okay, that's what I missed. Got it.
Okay?
It's times 10, not times 20. Got it.
Yeah.
Okay.
Times 10 versus 20. Or else you'd get answered B.
0.707 is really the square root of 2 divided by 2.
I said this is a very, very basic question. You have to know to do it right away. Interview job, you don't have any paper with you. No cell phone. They just ask very, very basic. They don't want to go to complicated circuitry. No. They just want to know you get a basic training or not. Okay, any question, anything? This will be posted on the YouTube tonight, okay? So whoever not follow it completely, you can go into the YouTube and try again. Okay, let's see. Let's see, next will be not the diode, will be DCNetwork. Okay. On this one, okay, you can do it, okay? I can give you the answer for you to do it. But before we doing that thing, okay, I want to go through new one. This was the one we want to do it today. Network theorem. Okay, what they say is using the shown with any circuit with 2 or more voltage source. You can see on that one, you get one here, you get one here, 2 voltage source. Keep one source while you must remove all of the other source. Only working with one source only. Okay? To remove the voltage source from the circuitry you shorted. To remove the current source from the circuit open it. Do the calculation for each circuitry, then add them up to get the answer. Okay, now I want to solving the problem for this circuitry. They say they want VB, that means right here. And they get 2 voltage source. Now we have to remove one at a time. So this one here, I take the 20 volt out. So when I take the 20 volt out, I short it, okay? You see that? Just short it. Okay? And now you see how the circuitry will be look like. So on this circuitry here, I want to calculate the VB1 here. Who tell me how to do it?
Oh.
You could do it the long baby way and add up the resistors and divide that into the voltage, get the current, and get the current. Once you get the current, you can say the current times 50. That'll give you the voltage drop across R1, and
No.
then it'll give you
No.
Voltage
You can use the
divider.
voltage divider rule.
Yeah.
I was going to
Okay.
say that.
You
I wasn't
can
allowed to finish.
I said, Mr. Smith, a little wrong here. You can calculate the current I, right? By take 40 divide R1 plus R2.
He don't let you finish.
Get that? Normally, okay, you can calculate the current I here. Okay, I will be 40 divide R1 plus
24 volts.
R2. Okay, and after you get I, you want the VB. VB means the voltage from the B to the ground. So VB equal I time R2. Okay. However, I said you can use voltage divider law. So VB1 will be 40 times R2 divide R1 plus R2.
There's two ways to skin a cat.
Yeah, but I prefer to.
You like the voltage divider rule to skin
Right.
your cat.
That's what I want.
Okay. Everybody had their preference, Mr. Pham.
Okay. So VB1 do calculation, you get 24 volts. Now, I calculate the second one. I will be remove this guy. Okay. I keep this one. So now I say remove 40. So you see that short here. And you get 20 volt here. And that's what I call a VB2. So same way, right? You can calculate the by voltage divider. Tell me, VB2 equal what?
20 times.
Very good. Time
R1,
R1 divide.
both of them, both
Yeah.
resistors.
R1
1
plus
plus 2. R1 plus R2.
R2.
8 volts.
Can't you also just take the voltage difference between the opposing sources and do it directly in one calculation?
Okay, so basically VR2 you get 8 volt. Is correct? VB2.
Right, sir.
Okay? And then you add them up. You get VB. Okay, VB will be 32 volt. This is the answer. That means you take 24, adding to 8. Okay, for this pocket here, for your guys, you don't have to do it if you know. If the thing is, we get the program only 1 year. However, if you go to the college or university, then you must know in detail. In this program, I don't expect you in order to solving for two 3 sources. The thing is very easy now. If you want anything, you run simulation, then you can get everything you need. Why we have to do calculation?
I have the simulation running if you want to see, Mr. Fan.
Yeah, I guarantee you simulate it, you can get the same answer. Okay, but let me try to get through this thing, not take too
Can I
long.
ask you a question about number 1?
Your question about VB1 or what?
Yeah, so I see that you have added 24 and 8, but the way the voltage sources are in the circuit, doesn't it mean they have to be subtracted? Or am I looking at it wrong?
Okay.
Yes, that's right. They are in opposite.
Yeah, because
So she'll remember at the top where it says network theorem superposition, the very last line says, do the calculation for each circuit and add up the results.
Okay, now I understand. When you're doing calculus of VB1, right?
Yeah.
So the first thing you get 40 volt, 40 volt, you get positive voltage. And the second thing you get 20 volt, you get, let's see, we calculate the VB1. VB1 we get 24, right?
Yeah.
Okay, 24. And now you get that will be the positive voltage. And when you get the VB2, if you get negative, you're adding up, they automatically subtract it. Okay? If they get the positive, then you're still adding up.
Okay.
Okay? So if I change the polarity 20 volt here, then you get negative. Okay?
But the current are
they can
current are
get a
opposite.
minus 8 volt. If I change that to a negative here.
No.
Okay, so it doesn't matter that the currents are going opposite of each other in the circuit because we don't look at the voltage sources together
Right.
on the circuit.
Just add them up.
Okay.
Okay.
Okay, but what if E1 and E2 are both 40 volts?
Cơm xong chưa?
Then the current is 0.
Which one? What is it?
Dọn là chỗ này có những vừa vải quá.
You're talking about VB1 or VB2?
Ôm lại mấy đứa kia nó học nhưng mà ôm lại.
They're asking if E2 was also 40 volts. So you had 2 equal voltage sources.
With opposing currents.
Here it's 0.
Well, it would be VB would be 40.
Đi ngoài về là không thấy nó rồi.
So I guess what you were trying to say is that by convention, disregard.
Regarding what?
Cutting off.
Okay, now what I'm saying is, for this to solve the problem, you have to remove the source one at a time, right? That's the first step. You remove the voltage source, sort it out. Okay, then you calculate for only one source. So the first thing, I removed 20 volt right here. I sort it out. So I do a calculation with 40 volt source. I get 24 volt. Any question on this thing?
No.
Okay. Then I remove the 40 volt right here. That sorted out. Then now you get 20 volt here, and you calculate the VB2. And VB2 will be using the same voltage divider, and you get 8 volt. Okay?
I got 12.
12 or 8. 8 volt, right? Is it I doing calculation wrong?
Can somebody calculate that? I don't know. I got 12.
It should be 8. It's 20 times 50 divided by 125.
So do I calculation right or wrong?
Yeah, it's
It's
8.
right.
You're
It is
correct.
correct.
It is
This
8.
VB
Okay.
is correct.
That 8 volt is correct.
What, Joe?
Okay, who can try on this problem here? I get 2 problems. Remember, keep only one source. Okay? If you remove the voltage, you must be shorted. If you remove the current source, you must be open. So this is the first one. They want to calculate the VR2. VR2 right here. Same thing like VB, if you want to say VB. Okay, that means from the B to the round. That's the same thing with voltage across R2.
Hey, Mr. Pham, in this case, you have R2 in parallel with R3.
Okay, now.
And then you use the
First
current
one.
divider law.
Okay, I draw the circuitry. I say, I check it out, sort it. Right?
Mm-hmm.
You look at the circuitry. Okay? And now I want to calculate the voltage of R2. That means you need to calculate the I2. VR2 will be equal I2 times R2. How do we calculate the I2?
We use the current divider law.
Perfect. Current divider law. I2 equal what?
R1.
2 amp.
No, it equals IT, which is 2 amps, because that's a
2
current
amp
source. Times, so R2 is equal to R3 over R2 plus R3.
R3.
I2 is equal to the 2 amps times R1 all over R1 plus R2.
No.
2 amps times R3.
And what?
R2.
Oh, I'm sorry. R3.
Divided by R2 plus R3.
Perfect.
R2.
It'd be about 0.4 amps.
Yeah, that's right, because the current comes out of R1 and splits up into R2 and R3.
Okay, after you get I2, you can calculate the VR2. We call that will be VB1. Here.
Actually, I3 is just I2 minus my 2 amps minus IR2. It's just a subtraction, right?
Okay, so 2 amp times 25, right?
No, it's 2 amps minus IR2 is equal to IR3.
Divide.
He's doing the I2 first.
100.
Okay.
equal what?
50 divided by 125.
0.4 amps.
0.4
amps.
And VB1 will be I joule times R joule.
Should be 40 volts.
Equal what?
40.
40 volts.
But I don't think we need to do this. We just need to subtract I2 from 2 amps, then we have I3.
Is it 40 volt?
Yes.
Okay. Now, this is VB joule. Okay, so next remove 2 amp source will be open. Okay. So
that's the same as R1 not being there, right?
R1 will be not using, right?
Right.
The current cannot go to the open circuit. So right now you will go back only this circuit here. So you want to calculate the VR2. Equal what? Using
divider.
Voltage divider. 10 volt times R joule divide R1 plus R joule. Okay, so what you get for VB2?
8 volt.
8 volt. VB2. And VB1 plus VB2. Okay, you get 48, right?
Yes.
Yeah, that normally to be very exciting. You're working with this kind of problem. The thing is, the time I'm working in the university, I not understand at all. Thing is lazy reading the textbook. In this program, you don't need the textbook, only the handout. Go over and over.
I'm thinking maybe we've skipped over the explanation of why a current source is replaced by an open circuit and a voltage source is replaced by a short circuit.
Yeah, that's the law, the rules. If you want to working with the superposition, you must follow. They say you only working only one source. The other must be removed. However, how do we remove? They get the law. You want to remove voltage, you must be shorted. You want to remove the current source, you must be open. That's the rules. We not make it. You must be following. If you go to college, go to university, you can learn more.
I see that we're going to be talking about Thevenin's theorems, and this relates to that because the internal impedance of a voltage source is 0, so you replace it by a short, and the internal impedance of a current source is infinite, so you replace it with an open circuit.
See, how come today they display this one? That's okay. Now, you know how the DMM can measure the resistance. Okay, I try to explain to you. You get a DMM here. Digital multimeter, positive, negative, and you get a resistance. Ah, so you already know how. You connect that one here, right? Negative to here. And they will be displayed how many ohm? 10 ohm, 100 ohm, for example. You see that? That's how we measure the resistance. However, do you know how the meter know it, the value? What will be happen? Okay, I told you. When you try to measure resistance, the DMM send the current out. I. Okay. Then they measure the voltage across here. V. Then they using formula I equal V divided to I. So that's why they get the value. You follow that?
The meter sends out its own generated voltage, correct?
They send out the current. Then they measure the voltage. That all happen inside the DMM.
But the generators,
We don't have any generator here.
The DM has an internal voltage output, correct? And
Yeah, they measure the voltage across R. That all happen inside the meter. We don't know how they do it. After they measure the voltage, they take the formula I equal V divided I. That gives you the value of resistor. Okay?
Hey, Mr. Pham, I missed that. So where did the 10 ohms and come from?
No, I given you example. That means they measure, they can get any value. Don't have to be 10. Depending on the resistor.
Oh, so the resistor was 10 ohms.
No, correct.
Okay.
And now I ask you another question here.
So it looks like a DMM can apply a known voltage and measure the current to figure out the resistance, or it can apply a known current and measure the voltage to figure out the resistance. Is that correct?
Yeah. Now you get R1, R2, R3, R4. and you get plus minus 24. Okay, I want to measure R3 with a meter. Positive, negative, DMM. So how do we connect? I say A, B, C. How do we connect the meter to measure R3?
Positive to point B,
Okay.
negative to point
Okay,
C.
I want measure R3. Okay, you say DMM high. Connect to B, right?
Yes.
And DMM low.
You see.
Low to C.
Yeah, but you have to disconnect the power source.
Okay.
You're measuring voltage, right, Mr. Pham?
What?
Are you measuring voltage?
I measure the ohm. Measure R.
Oh, if you're measuring R, then you need to turn the voltage, the power off.
Yeah.
Why?
Wait a minute. You said you're using a DMM and you're measuring resistance. If you're measuring resistance, you need to cut the power.
DMM has its own power output to measure a resistor.
Why?
No. I'm talking about the the power
right.
on the circuit.
I understand you right. However, my question is why we have to remove the power? Huh?
Because
you'll damage your meter.
multimeter has own current.
Okay, now, if I'm not removed, see what happened? Positive standing here, right? Negative will be connected into here. Correct?
Right.
Okay, now, if you not remove, see what happened? Like I already explained to you. When they measure resistance, they send the current out, right? You see that?
Right.
So when the current out here, okay, if you not remove that one, and this current, okay, they get also this current here. See? So that's messing up. Okay? And you cannot measure. So now they say, take that out. Okay. But when you take it out here, you still cannot measure to get the right value. You understand why?
Yeah,
because R3 and R4 are in series, but they're in parallel with R2 because R2 and R4 is grounded.
Okay, so now I can tell you when the current I go this way, okay? Current I here. Go to here. So basically, that current will be going this way and going this way, right?
Right.
So that means the value of the R3 will be not right. So
hey,
that
Mr.
will
Pham.
be what?
Hey, Mr. Pham.
Yeah.
R3, is that because R3 and R4 are really like one resistor, correct? Because they're in series.
In series, no big deal.
I know, but my point is that one end of R3 is connected to the top end of R2, and since R2 and R4 are grounded, then that's like measuring two resistors in parallel.
Right. But what I try to bring it up here, to telling you when the current from DMM sent to that point B, then one go to R3, R4, and another will be go to R2. So the current is not exactly the current DMM1. And the value of R3 will be not really get a correct value.
So you have to isolate R3.
No, you cannot. The thing is in the, you working in the board, you cannot touch, remove anything on the circuit board. That's only telling you, we cannot measure, the value of the jitter inside the circuitry.
Oh, I think I see what you're saying, Mr. Fan. You're saying in the real world, these resistors are because they use automated machines to solder them to the circuit board. We can't be removing the resistors.
No way.
So
Right.
we have to come up with another way of measuring resistance.
Right. So the measurement is basically impossible to do.
In this case, normally you can use in the color code if you want. Or you can testing with the voltage. If you get a wrong voltage value, then you can get either wrong with R3, R2, or R4, or R1. But you take the measurement, resistance, that is not the way.
How about if we take alligator clips and jump a wire across R2 and R4?
Don't touch to the circuit board.
Oh, we got to figure out something. We're going to get fired, Mr. Fan.
No. you get layoff.
That's the same thing. Hey, Mr. Pham. So basically, that's why in electronics, engineers and veteran technicians always say you need to take voltage drop readings to get what you want. Is that correct?
Right.
Why are you wearing those? I thought we were going for a walk.
You have to take voltage drops to get what you want. Is that correct?
Yeah.
Okay.
Yeah, it's very difficult to get into a circuit, to interrupt a
Only
circuit.
thing that when you apply voltage, you measure the voltage. Something not right, then you can say, okay, maybe R1, R2, R3, R4. The thing is when you're doing testing, you don't have to be understand completely. Engineer already telling you. They say you apply 20 volts, you measure VB, you're supposed to get 5 volts. If you measure that, you not get 5, some wrong, then how you fix it? Or they say measure VC, whatever voltage engineer wanted, then you just measure to see you get it or not.
Mr. Pham, here's a question.
Yeah.
All right, so say that circuit's complete without the 20 volts disconnected to A, right? The circuit doesn't have any disconnects at all. And we're assuming that at A and C, we know what the voltage drops are, right? Just assume we already know what the voltage drops are, but we need to check the resistance.
Now,
right? Wait, hold on. I'm trying to come up with an answer here real quick to respond to what you're asking. Now that DM, it only has a specific amount of voltage and current that it self generates, correct? It only generates like 2 volts, 3 volts, right? So the voltage that the DM generates into that circuit needs to be variable. It needs to have an adjustment at between R1 and R2 so that you can have the correct voltage inputs into the circuit.
now I'm telling you.
You have to have a variable DM that allows the voltage adjustments for both sides, but that standard DM doesn't have that capability.
Okay, Whatever happened inside DMM, we don't care. We care is when you measure R3, you connect this way, current will be sending out. Whatever current, I don't care, but current sending out. So when they go to this point here, current can go to here, and current will be go the other side here. Okay, so that means the current DMM1 is not that current. So that's why after they measure the voltage across R3, they're using R equal V divided to I. You get a wrong I, okay? Then the value will be wrong. And the voltage also. So that's what I'm saying. Hey, we're not supposed to measure the resistor on the board. Only way you can do when they tell you to test it, apply voltage here, measure the V right here. They supposed to get 5 volts. And now you not get 5 volts. Okay? Then they can be wrong with R1, R2, R3, R4. Then you can replay either one. You get that 5 volts.
Hey, Mr. Pham, can I ask you a question?
You get a question? Go ahead.
Yeah, I got a question. Hey,
Yeah,
Mr.
go ahead.
Pham, so in the real world at these job sites, when it comes to resistance and current, they don't want you breaking the circuit to measure the current or to measure resistance.
Yeah, absolutely.
They do not.
Yeah, they do not.
Okay.
Like
So-
you guys doing on the left volt, like the other instructor showed you. They get a circuit board already built. You want to measure the current. You cannot break the circuit. So that's why the left volt, they already know that. So they have to put the jumper. They open for you guys to measure the current. If not measure the current, that jumper will be connected to that. So that's why you don't damage the circuit board.
But in a lot of these simulations, when we do break the circuit, we're doing it because we're in school, we're in class, and we can do it here. But wait a minute. We're in school, we're in class, we can do things like that here. But when we get out in the real world and industry, we're not supposed to do that.
No, Joe, it's should you ask a question and get laid off, or wait and try to figure out what you're supposed to do? If you're not asking questions, then either way, you're not going to get your work done.
The thing is when you try to break the circuitry, guarantee you get laid off. The thing is they talk, you don't know what to do.
All right.
You know, in my experience, it's the best approach to troubleshooting is to take voltage profiles and
Then
compare them with
bring it up for you.
with the schematic, right?
One thing.
That's the best way.
Hey, that sounds good.
Okay, I just bring it up for you guys to understand. When you testing the circuit board, you cannot do anything on that circuit board. Except you say, I found R1 is not working, then you have to replay it.
In the worst case scenario, just ask questions.
Yeah.
Or have Mr. Pham's phone number.
Let me give you can I give you an example?
Oh man, wait, otherwise then I'll pass. Thevenin theorem.
Mr. Pham.
Yeah.
Richard has something to ask you.
Yeah. I was thinking back to way back in my past when I was given a circuit board that was malfunctioning. And it turned out that the engineer who designed the board installed a 15 megohm resistor. And it turned out that the residual resins on the PC board had less resistance. And so there was leakage current. And the only way I could discover that why the board was malfunctioning was that the leakage path had less resistance than this huge 15 megohm resistor. And I solved the problem by measuring voltages. I could not disturb the circuit. I couldn't break a circuit, right? So that's just like a lesson from my past that explains why you can't break up a circuit to understand why it's working or not working. So just a little bit of history that explains.
You're saying compare voltage drops, correct?
Because that's almost all you have in a complete circuit without breaking up the circuit.
Okay.
Okay, thanks.
Now I telling you one thing for you guys know a little more about the company. In a company, to get two different types for technician. First thing I talking normally, test technician. Okay, so basically you will be test the board already working. Okay, that means the board already working and company send to the customer. Okay, after for a while they found something wrong, they send it back for your guy to fix it. That means the board already working. And the second technician will be engineering tech. That means I am engineer, I design circuitry. I say, okay, go ahead, build and test. That means you can remove the wire, you can do anything. That have to be in protocol, not build. You have to, normally I am in a wide wrap, okay? Wide wrap the circuitry and test it. You found something wrong, current, whatever, then you can open to measure it. That's a different type of the technician. Okay. However, normally in the company, you just a test and the technician, you just test the board, they already working. Something burn out, something, lose something inside the circuitry. That's why you need to fix. But you cannot remove something in order to troubleshoot it. If they get R1, R2, R3, gen R1 first, not fix the problem, gen R2. Then you can gen R3. You cannot do it by yourself. You want to change the resistor, change the part, you have to give it a assembler. They did it, not you. Okay.
So basically the job that you do is just test it, and whatever there's problem in the circuit, you gotta tell it to the whoever's gonna replace it or not.
Yeah. You say, okay, go ahead and remove R1 for me. And after they put a new one in, they give back to you, you test again. If it pass, you're lucky. If it still fail, and now you say gen R2.
You get fired.
Not yet. If you get 3 resistors, you have to change on 3, you get a problem. And sometimes, like, I'm engineer, they working, they want to change R1, then I say, tell me why? Why you want to change that resistor? They have to prove it.
So you have to give a hard time to the technician first before they have to replace
Not
it.
hard time, but I want them to learn the way technician working. Okay?
Got it.
Now, Thevenin. Okay, before we go Thevenin, I want to show you a few things here to get you understand. Okay, now if you get the circuitry this way, one, two, three, four. And that will be RL. Now, what is RL?
Load.
Okay. RL means load. Load resistance.
Hey, Mr. Pham, when you use the term load, that could be a speaker or anything else as well, right?
Right. Now, that's what I try to explain. Load resistor may not belong to the system. If you get DMM, you want to measure resistance, positive, negative. This resistance will be load. You understand the load. That means they not belong to the DMM. You can change any resistor you want. Same thing. In your stereo system, load will be speaker. You can change any speaker you want, but you cannot change anything inside. Okay? That's what they call load, not depend on the system. Okay, so now, Thevenin try to do. They said everything here. Okay? Everything here. Inside the system. They want to combine. Okay? They want to combine into the circuitry. Only one source. And only one resistor. Okay? And this source here, they call a V Thevenin. And resistor will be R Thevenin. So now, if you want to measure the load, you just connect here. That will be a load. So you understand the concept for the circuit inside system to get too many different resistors. They want to combine it into one, only one. That's what they call R Thevenin. And even you can get more source here. How many source they don't care, but they want combine to get only one source, and that we call a V Thevenin. So now I want to measure the resistance. I just connect into here, okay? Connect into here so I can measure it. That is Thevenin. Okay, Thevenin here. See what they said. Up any source and the components, no matter how they are interconnected, can be represented by an equivalent by one source we call V Thevenin, and only one resistor that will be a Thevenin. Okay. Now, that means they want only one source. Okay. You can see that we're doing calculation, and we can see you can get only one voltage. Okay. And also only one resistor. To calculate the VThevenin, they're telling you remove the load, then calculate the voltage across the open circuit. So now you can see, for this circuitry, this is the load here, I remove that one out. Okay, you can see that load right here. Remove that first. Okay, then, okay, remove the source. Okay, that is calculate the RThevenin. Now, after you remove the load, this is the voltage looking into the circuitry. I want VTH. Can you tell me for this circuitry what VTH equal?
V out.
Voltage threshold.
Let's see. I see it in here. They say something. No.
You use the
It's the
voltage
drop
divider.
across the 1.5K.
Okay. When you're looking into here, you can see
No,
the voltage will be here, right?
Right.
That means the VTH, same thing VR2.
So use the voltage divider rule.
Okay,
1.5,
yeah.
1.5K
Same
over
thing,
1.
right? You cannot using VR2 equal 20 volt.
Divided.
Time R2 divide
R1, R2.
plus R2. So that's why easy to calculate the VThevenin. And if you're doing calculation, I believe you get 11.1 volt. Okay? And now, the next, calculate the RThevenin. Remove own source. Then calculate RThevenin across the open circuit. Okay? So the same way to remove the source, voltage source will be shorted. Out, current source must be open. So on this circuitry, I want to calculate the RThevenin. First thing I need to remove this guy. So now they short it here. Okay. Then from the open circuitry, you're looking into that to see which resistor series parallel. So you supposed to be looking from RThevenin here, you're looking into the current coming in, and they go in here, they go one here, they go one here. That only telling you R1, R2 will be parallel. So you can calculate RThevenin. R1 time R2 divide they're telling you RThevenin equal R1 parallel R2. So that's why you can get RThevenin equal 3.2K. Okay? So now from this circuitry here, you move to this circuit and you put a R load back here. If you want to calculate the current, easy, right? You can take your V Thevenin divide R Thevenin plus RL. Okay? So, basically, Thevenin, they want to combine, okay, to a single circuitry, only one source and only one resistor. The source will be V Thevenin and the resistor will be R Thevenin in series. Okay, to calculate the V Thevenin, then first thing you must remove the load. Then from the load to looking into the circuitry, you can calculate the voltage. Okay, and if you want to calculate the resistance R Thevenin, then you have to remove on the source. When they say remove on the source, that means if you remove voltage, you short it. If you remove current, you open. Okay? Then from the open circuitry, looking into the circuitry, you see, try to see which resistance in series or in parallel. Okay? Now, that number you here, okay, 20 volt here. Okay, let's see. Now, number 5 here. Can you calculate the V Thevenin? That means you take out that guy, open. And now you take the VTS. That means the voltage from A to B, and basically you open, that's the same voltage VR2. Doing the same thing, okay? VR2 will be equal 20 volt times R2 divide R1 plus R2. That's why you get V Thevenin 12 volt. Okay? Now if you get the, try to calculate the R Thevenin, still open here, and the short must be shorted. And from here you're looking into that. That means if the current go here, they will be go into R1 and go into R2. So two resistor, okay, R1, R2 will be parallel. And that's why you can get that value here. Okay, let's see, that is the same thing. You just doing exactly the same thing. Only thing, the voltage now will be negative. Okay? That's a very hard part for the engineer. Okay? In the past, when I start learning, I not quite understand. But it's okay now. You your guy, you don't have to go too much thing on this two things. Okay? Theorem for superposition and also for Thevenin equivalent. Okay? So I will stop that one. I given you the answer for the handout here, and we not doing for you. Let's see. Take one handout here. Okay. I can share that guy here. Okay, for that one here, anything here, okay, I just given you the answer. This is the answer here. Okay, what will happen to current passing through a resistor if the voltage drop across is double and the resistance is half? So the answer will be double. Okay, and that one they just given to you. Okay, formula law here. Now for this circuitry, okay, they want to find the current I and I2. Okay, so basically I2 they get 0.5 ampere. Okay, I they get 1 ampere. In order to do it, we try to telling you. First thing, they say this register in parallel. So they get 4 ohm. 4 ohm series with 6 ohm. Okay, and mean 10 ohm this side, 10 ohm this side parallel. So that's why you get 5 ohm. Okay, and now you get a voltage 9 volt here. You divide by total resistance. Okay, that means the total will be 9 ohm. I equal V divide R. You get 1 amp. And I2 mean here. Okay, and you can get 0.5. The thing I choose resistor equal. Okay, only on that one here, no. Then on that guy, okay, and next one here. Okay, number 4. That one we done. And now for this circuitry here, they want total resistance, whatever here. I already given you the answer here. Okay, you can looking at 1, 2, 3, 4, 5, 6, whatever here. You get that. Okay, that only thing. That one we already do it for you. Okay, and we still recording, so you can look into the recorder, on the YouTube. You can try to look over everything here. Okay, so any question? The thing we try to give you very, very basic. Okay, it's not hard to learn. And we will be get back to the lab very soon. When we go back to the lab, take only one day lecture Monday, and take two will be only one day lecture Tuesday. The rest you have to do your lab.
Question, Mr.
Yeah. Go ahead.
Thevenin's theorem helps determine a circuit where there's multiple components and you can't remove the component to test, correct? So it's more mathematical than it is with equipment, correct?
Right.
Thank you.
I might elaborate on that a bit. That Thevenin's theorem says that no matter how complex a voltage source you have, it could have a voltage source and many, many resistances, whatever, and it's a black box. And so finding out the equivalent of that is easy. You just measure the open circuit voltage of the black box and the short circuit current of the black box. And then the equivalent of that source is the open circuit voltage in series with the with the resistance that is the voltage divided by the current. That's it. It's very simple. It transforms any complex voltage source into a simple voltage source in series with a source resistance. It's that simple.
Okay, but what I want to tell you one thing. When you're working at the company, you run the test, they fail. You must be troubleshooting. But don't try to remove or do anything with the circuit. You're only using meter, oscilloscope in order to troubleshooting, measure it, decide where wrong, what needs to be fixed, okay? You
Right.
cannot remove doing anything that will be damage the circuit board. Like you say,
That's right.
okay, you leave
That's
the
absolutely
resistor.
that's absolutely right. That's absolutely right. You just measured the open circuit voltage and the short circuit current, and you have the voltage and the internal resistance in series with the voltage source, and you're done.
Yeah, that vary depending on the company and what. When you get the job, okay, first thing they must be training for you. You get along with the company, okay? Some people will be work with you. After you get along.
I'm sorry, Mr. Fan. I apologize if I'm being disrespectful, but Thevenin's equivalent is just as I stated. It's the open circuit voltage divided by the closed circuit current. It's not a matter of what company you're being tested by. That's Thevenin's equivalent.
That's okay, but what I'm saying, when you're testing, what happened? You plug the circuit board into the system, okay? And now you run the test. The test part, that means okay, but the test failed, you take care. And only what they can give it to you and in the test system is a meter and the oscilloscope. Whatever you want to do.
I think Mr. Pham's suggesting that you should know the other route as well in case you need to troubleshoot.
Yeah, the thing is route for sure. You know, you will be know that where is the route. In order to connect a meter, you connect the oscilloscope. Then you can measure.
Do as less damage as possible so you stay employed.
The problem you won, you check YouTube, you're fired.
I'm good with that, but I'm retired, so I don't care about being fired.
Okay, now I'm talking about your left mode. When you go into the lab to do your left mode, first thing they assign for you what board you plug it in to the system, and you follow the instruction to do your lab. Okay. So when you try to connect everything and you measure, you get it wrong.
We can hear you, Mr. Smith.
You have to know how to correct the problem. Either you can build a circuit wrong, missing, jumper. Or maybe you apply the sideways, they're not coming out right. Or maybe your oscilloscope, they're not working. You see that? Too many unknown. Then that's why you need the engineering lab assistant and assistant to helping to you to fix the problem. Make sure when you enter data they wrong. Don't do anything if you don't know how to do what to do. Then just raise your hand. They coming to help you out. Same thing in the company. You only do what you know how to do what to do. Don't guess. Not lucky in electronic. That's why I spend a lot of time trying to figure out a way to help you guys out. You want to be a technician. I really, happy you can get the job. You can email back to me, okay? Then that will be motivate, helping me keep doing. Okay? So, we'll see you guys on Wednesday.
Thank you, Mr. Pham.
Thank
you, Mr. Pham. Thanks, Sam.
Night.
Mr. Pham.
Good night.
Thank you.
Thank
Well,
you, Mr. Pham.
Everyone,
Okay.
thank you.
Yeah, I don't feel like this is an